Hello guys, today I'm going to explain you how can we solve this problem maximum sum circular subarray from Leetcode's May challenge. Here the circular array means like this last element is connected to an first element. If it was not a circular array, we Kadane's algorithm to find the maximum sum subarray. But here the difference is that the last element is also connected, so we could get the better result by checking if we can get some elements from on the right hand side, like from the left, from the end, and some elements from the beginning. Some prefix and some suffix would add up to the best result. For example, in here, as we can see, let me show you. So if it was a regular array, we would have got 7 as the maximum result, but this is not the regular array, this is a circular array, so we would instead choose the last element and the first element, and this would give us the best result, which is 10. In here as well, we can get the best result from the regular subarray here itself, but we can also choose to take this 2, -1 and 3 as well, which would also give you 4. So if you see the example, so we could get 3 -1 2 as well, or 2 -1 3. Both of them would give you the best result equally. And here, yeah, 3 itself is giving the best result, and 3 -2 and 2 are also giving the same. Both of them are the best result from the regular array. Like, we cannot get the best result by choosing some circular subarray. Alright, so how can you solve this? First of all, how can we simulate a regular array into a circular array? So we are given a circular array. This is not a doubly or circularly linked list, circular linked list. So how can we simulate? So the idea here is that we can easily assume that a circular subarray means, because we are only allowed to choose one element only once, so we can append just one array to the right of it, like duplicate the array. So for example, 3 4 minus 3, 3 4 5 minus 3 minus 8 10, we can just assume that we have another array here appended to it, and then we can simulate, keeping in mind that we are not going to choose the same array, same element twice. So now that we know how can we simulate, how can we get the best result out of here? Alright, so there are only two cases possible where we can find the best result. The first case is that when we will have our best answer in the regular array, like in the first array itself, as you can see here. So we can find the best result from here, and then we'll have the second case where the best answer lies somewhere here, like it's overlapping the first array and going into the second array. The second array is nothing but the first two elements from here, so that means it's a circular way. So what I am saying is we can choose the best result from both of these. Like, first we will find the regular array maximum sum, and then we will try to find what's the best result that we can get like from this particular case. If both of them, then we will compare, and we can see which is the best result. All right, so how can we do that? So to find the best result from here is pretty simple. We can use the Kadane's algorithm to find this. But how can we find the best result from the case 2? All right, so let me explain you first by showing you how can we actually assume case 2 into a different manner. Like, how can we see this problem in a different manner? So what we were given is, if we have to get the best result from circular manner, let's say this was the best result that we could get from here till here, we could also see this problem in a different manner, that instead of choosing the best result from the best two results from, like, this is something, we are getting the best sum from prefix and best sum of suffix, but instead of doing that, we could also do some sort of thinking, and we can arrive on this conclusion that the best result would give us only if we are able to find the least sum subarray from the regular array itself. So this would also be equal to saying that we will get the maximum sum from the two sides if we are able to find somewhere in the middle of the array some particular subarray, like a contiguous part of it which has the least amount of sum. Alright, so what we could simply do is, in this case, first find all the sum, and then we can just reduce, subtract this particular amount of sum, which is the least amount of sum that we can get. This would give us the best result. So instead of trying to append one array and finding this, where you will have to take care of multiple cases, like we are not considering the duplicate elements and all, we could simply assume that we are supposed to only calculate the minimum subarray from this given regular array. So how can we do that? Let's take an example from each of them. So let me first find an example. Yeah, so here this example shows the case 1, where we'll get the best result in the subarray itself. So here you can see 8138 will get the answer as equals to 30. Now if we will choose the example 2, here we are getting the best result from 1138, and minus, we'll choose the first two elements from here as well, so which will give you 24. All right, so and as I said, we could simply also get the similar result as we got from this case 2. Sorry, yeah, the case 2, where we would find the best suffix result and best prefix result and add them up. Instead of doing that, what we could have simply done is find the least amount of sum that we will get from this regular subarray. As you can see from here, the least amount of sum we'll get from, sorry, this is not the example. Here you go. Yep. Yep. All right, so as I said, we can simply find the total sum from here, and then we can add, yeah, we can subtract the least amount of sum that we are getting from this subarray. This will guarantee that we are getting the maximum sum from the maximum of the values from the prefix sum and the suffix sum. This would also give the same result. Now that we know that, how are we going to do for the regular subarray the maximum amount of sum that we can get, contiguous sum, we can do that, and then in a similar manner we can find the minimum sum that we can get from here. So I'm going to explain you how can we do that. So here, yeah, case 1 and case 2 are the best results that we can get, and like the case 1 will tell you the best sum that we can get, and the case 2 will tell you the minimum sum that we can get. And then we have initialized the current sum like we do for Kadane algorithm. We are in parallel also calculating the total sum, yeah, and then we'll find the maximum sum using similar manner. And as you can see, I'm skipping to calculate in case if the elements, if I'm basically I am not choosing the last two elements, because if the minimum sum is this whole array itself, we will not get the best result. So that's why I'm skipping that. And yeah, in the end I'm just subtracting total amount of sum from the case 2, and we'll get the overall answer for case 2, and then we'll compare both of them to get the best answer from a circular subarray. Alright, so hope I'm able to explain this. If there is any question, you can ask in the comment section. Thanks for watching this video, guys.